In this part, I am going to discuss electric field intensity. So, what is electric field intensity? As the region surrounding an electric charge or a group of charges in which another charge experiences a force is called as electric field, and the intensity of electric field at that point in the field is defined as the force experienced by a unit positive charge placed at that point. So what is I am going to discuss here, you can see that if we have a charge Q and this is the region here, and if I brought another charge Q at this point, so when I brought this charge Q, then it will experience a force because of this charge capital Q. So the force will be applied on that charge which I brought to the near to the charge Q. So a force will be applied to that charge, and the region here where it will experience this force because of this charge is called electric field intensity. So this is the main point here. The region where it feels the experience of that force because of this charge, this is called electric field intensity. So I will go in more detail to explain what is electric field intensity. So I will show you with some example here. So we can take an example. If we have a charge Q1 and I just brought a charge here plus 2 coulomb, so it will feel a force which will be F1 is equal to 1 over 4 pi epsilon naught Q1 into 2 coulomb divided by distance between these two charges. So I am considering here the distance between these two charges is R. So the square of this distance between the charges. In second case, I am taking same source charge here Q1 and I brought another charge here whose magnitude is plus 3 coulomb. So its force F1 is 1 over 4 pi epsilon naught Q1 into 3 coulomb divided by R square. So here you can see that in both cases the source charges are same, plus Q1 and plus Q1, and this term is also same, 1 over 4 pi epsilon naught Q1 over R square. In both cases this term is same, you can see here. So this is the common term here. What is changing here is this point charge which we brought near to the source charge. In this case this is 2 coulomb and in this case this is 3 coulomb. So I can write it as F1 is equal to 1 over 4 pi epsilon naught Q1 over R square into 2 coulomb, and in this case this F2, this is F2 actually, so F2 is 1 over 4 pi epsilon naught Q1 over R square into 3 coulomb. So both cases we have this common term, and basically this is called electric field intensity. This is electric field intensity, and it is also a vector field, so we cannot say that it is force, We cannot say it is force. So there are many definitions which claim that the electric field intensity is the force experienced by the charge. So but it has both things have different units. Force has different units and electric fields has different units, if you will see. So this is not the force actually. So if I take a charge, source charge plus q, and another point charge which I brought close to this source charge, which is q dash, so it will feel that this point charge electric field E, and what will be the magnitude of this electric field is, which is equal to 1 over 4 pi epsilon naught into q by r square. So you can note here I am taking the source charge here, not this point charge which just brought close to the source charge. So this is the electric field intensity, and this is the case when medium is air. Sometimes you will get the problem here when there will be a medium between these source charge and this point charge. So for that case, the expression will be changed by this 4 pi epsilon q over r square. Epsilon is here, epsilon r, epsilon naught. This is the relative permittivity and this is the free space permittivity. Now you can see here the vector form of electric field intensity. So consider a Cartesian coordinate system in which the charge q, you can see here this is charge q here and is located at distance r from the origin. So let us find the electric field intensity at point P, which is at distance r from the origin. So electric field intensity at point P is given as E is equal to source charge is q, which is here, q divided by 4 pi r square. So 4 pi epsilon naught modulus of r minus r1 whole square unit vector ar. Here is the unit vector. This is unit positive charge. Now unit vector ar is, you can find out this unit vector ar, r minus r1 divided by modulus of r minus r1. So electric field will be equal to q over 4 pi epsilon naught r minus r1 modulus of r minus r1 q. So this is the vector form representation of electric field intensity. In next video, I will show you the electric field intensity due to a system of charges when we have a number of charges located at different distances. Thank you.